This problem here, we're starting to generalize things by having to deal with more and more variables, and that's a really important part of what we're trying to develop in Math 11 is generalizations. Looking at the math and not being able to use numbers to calculate things. So we're moving away from all this calculating to generalizing things with variables. So here I've been given two unknown parts of this. I do know the y-intercept. So if I'm going to sketch this, maybe I'm just going to sketch a quick graph here. I know my y-intercept's at 3, and I've been given two more coordinates. So I've been given 3 coordinates. So 1 over, 2 up, somewhere around there. -2, -7. So somewhere down here. Okay, so I know that my graph is probably going to go something like that. Okay, it's hard to tell, okay, but those my 3 points kind of indicate to me I got a sense of that parabola. So if I have a physical sense of that parabola, I must have enough algebraic pieces to be able to solve this algebraically. So basically I have two unknowns. I can't seem to be able to figure out A or B from these coordinates. So I think I'm going to have to come up with two relationships to solve for the two unknown values. And I'm going to use the two relationships by just plugging in the x and y. So I get A times 1 squared plus B times 1 plus 3. Simplifying that, I get A plus B, and I'm going to subtract 3 from both sides, is equal to -1. Okay, so that's equation 1. Equation 2 is using the other coordinate. So I end up with 4a, -2 squared, minus 2b plus 3. And so when I solve this, I get -10 equals 4a minus 2b. I'm just going to simplify this equation. And the reason why I'm simplifying this is just because if I do this, my b coefficients match. I'm just going to add these together. So I'm going to take 1, and I'm going to add equation 2. It's 2a minus b. I get -6 equals 3a. Solving for a, I get a equals -2. And that looks about right. I've got an upside down parabola looking something like that. Okay, so there's my a value. I do still need to solve for b, so I need to plug that back into one of these equations. So I'm going to just plug it back into a here, or just plug it into equation 1. So back into equation 1, plugging it back into there, I'm going to get -1 is equal to -2 plus b. Okay, so b is equal to +1. So there it is. I've solved for a and b, so I know my quadratic looks like this. F of x is equal to -2x squared, yeah, upside down parabola, plus x plus 3. Okay, so there's my parabola. I had two unknowns, so I had to come up with two relationships to solve for those two unknowns. For this one here, we have the quadratic function. We just have a point, so let's just quickly sketch this. I do want to know where the vertex is, so I'm just going to quickly solve for p. So p is equal to -4 over 2 times 2, so I'm going to get p value of 1. So if p is 1, actually, why don't we actually solve for the vertex too? If I know the p value, if I know the x-coordinate of the vertex, I plug in 1, I get 2 minus 4 plus 3, so the vertex is going to be at 1 and 1. So there's my vertex, and I have, it's going to go something like that, a y-intercept of 3, and m and n is some point on that parabola. Now, where do I draw it then? Well, essentially I can draw it anywhere I want. So I'm just going to draw it in a convenient spot here. I'm just going to say that M and N. And what am I looking for? I'm looking for this coordinate here, which I'll call X and N. Okay, and we know that that point must be symmetrical across X equals 1. So how do I find the location of this coordinate when I don't even know the numbers for this? Well, this is what I meant about generalization. We want to start generalizing this in terms of its relationship. And so we're not calculating. We want to know what is the relationship we need to use to understand the location of this X coordinate. And it's this idea of symmetry across that middle. So I'm going to use the average formula. So M plus X divided by 2 is equal to the middle point 1. And so this is my relationship to find the middle. Now I can calculate a distance here, go 1 minus M and then find that distance over here. I could do all that calculation, but this is much easier to do because now I just solve for X. So X is equal to 2 minus M. So that's the coordinate of the point that's symmetrical. This coordinate is 2 minus M, comma, N. Right? That is now, I've now found the X position in terms of the variable M.